Physicality.
Good evening, everyone. Thank you for coming. I'm very pleased to welcome Dan. Sibert is going to talk, and Danny Hyam. So it's Dan and Danny, also from Foster and Partners. He's not going to talk, I think, but he might do. He might chip in.
If I can jump him into it.
Yeah. So look, thanks very much for coming. Just to mention something which I might show you later for anyone that's interested, is that we have the archive of films of these lectures. There's about 100 online. There's possibly about another 20 to be uploaded. Adam Thwaites kind of sort of brilliantly has created, using some sort of AI tool, which he may, there he is at the back, he may describe later, but so if you go to that website, there's a link, and there's a search mechanism to find stuff within those 100 plus talks. And it's very interesting because it's, well, whatever, you type a word in or you type differently, and it takes you to the talk that thing was mentioned in, or whatever. So it's a very useful resource. And any third years, a couple of third years, might be quite a good way of doing your coursework. But anyway, but hand over. I think I'm going to keep this microphone. This one's, yes. So thank you very much.
Okay, cool. Let me get my clicker. So, hello, I'm called Dan Sibert, and for my sins, I've been at Foster's for 30 years since I finished at the Bartlett, interestingly enough. And what we're going to talk about tonight has been accused of being a bit niche by some of my friends, but it's sort of one of my obsessions in terms of how we work between these two really interesting media, the digital piece, and what do we do to test that with the physical. And I thought, particularly because it's a construction thing, what you'll really see here, I think, is what the workflow of Foster's really is about at its top end, and what are we doing and how are we doing it, and hopefully it'll give you a sense of what that can be. So we've got these sort of 4 projects or 3 projects to have a look at. We're going to start with the Smithsonian. We're going to talk about the China Merchants Bank, which is a big one that I'm doing in China at the moment. And then we're going to finish with a project called Soleil, which is in Dubai, which are some of these bits which we talked about. So just a little bit about Foster's. We're architects. We've been around, I think, for upwards of 50 years now, which is interesting. And I think I just want to talk about one thing, and really the point of this talk is a sort of idea that technology has always been part of our company, and it sort of starts off as this idea of being a high-tech architect, and what that meant at that point was, I think, probably the technology in the buildings. There was another part of it always about how you made design, and that maybe is, for me, as interesting, but there's definitely a positivity about the idea of technology within Foster & Partners, about that is something that can be a force for good, and that if we use it appropriately, it will be a force for good. So I think that's interesting. These are a few of our projects around the world. We're also very interested in infrastructure as well, so we sort of bridge that gap between what a building is and the spaces between buildings, and the other parts of the wider world. And I think that scale takes into some interesting places. It means that some of our buildings become very well known, as we see, which I think is quite interesting, this sort of idea of what the image of a building actually is. But we also then take it to this scale, and we'll talk a lot about that today, about we're quite well known for the detail side of things, and how does that become something? How do you develop a architecture that is not only about the big picture, but also about how you then achieve something, and what does it mean to achieve something in reality that feels very, very close to what you started off with. And those are some of the sort of product pieces that we've done. The middle one is actually one of my favourite spaces, which is at the Maggie Centre in Manchester, and it's this entirely curated space that is there for cancer patients to discuss their recovery, hopefully, within this piece. And obviously it looks entirely like a potting shed, which is the purpose of that. The product there is actually the rather lovely table that's rolling around and kind of linking into a kind of idea of Manchester and the railway tracks that were on the site beforehand. So this is the studio. So primarily in London, but we have now, I think, over 15 studios around the world, but most of the design is done in London. A lot of the stuff we're going to talk about is based in our London home in terms of what we do. That's why we keep most of our design piece together. And we tend to work all around the world. I think when I probably started there, it might have been maybe 50-50 between what was in the UK and what was international. It's now probably 90-10 in terms of where we are internationally. So the world has sort of very much that way for us. We kind of have ended up going very international, and most of our projects tend to be there. So you can see there's sort of clusters. Is it still working? Yes, just about. So you can see there's sort of clusters, obviously a lot in Europe, quite a lot in the United States, and quite a lot in China. But it's sort of, what's really nice is it gets us to open up to all these different parts of the world and what they mean and how to work with people within them. Okay. This piece will become a little bit more clear in a bit. We're not just architects, and I think that I'll talk about this again in a bit, but the number of voices is very key to us, that technology maybe is an idea within it, but it's also that the more detail that we can have, the more data that we can have about an issue of design, the better we are. And to a certain extent, that's where we're going when we're talking about this idea that between the physical and the digital is, can we effectively test things with more detail, with more experience to actually get the right result at the end of it. But this is some of our kind of internal structure. I call it the OG because it is for me. I mean, this is a bit of a personal journey, as I said. That's why it's a bit niche. I started this project, I think, around the time in 2000, and this is the Great Court. This was the first of the Foster projects that really, I think, if you think about this and you think of Swiss Free, is about the same time, and they're beginning to use a scripted workflow. And it's the very, very early part of scripting here, before all the quite easy stuff that you're seeing now, I would say, in terms of its interface with you, and we'll see what the interface looked like at this point. But this was a competition that I led the team on and won, which was great. And it's in DC, and it's this building here that was actually the patent office of DC. It's the third oldest building in Washington. And what we were going to do was we were going to cover over this courtyard, and that was the purpose of the competition. And it's the Smithsonian's American Art and Portrait Gallery. So the client was amazing. It was like you had these art historians as your client, which was really interesting. Yeah, so there's a sort of section through it. This is what we had to do. We had to cover it over, and our basic diagram was to do something like this. Obviously, it's actually in the other direction, was to produce a shell structure. We had these 8 columns. We're going to produce a shell structure, and that was going to give us the lightest possible roof. The catenary idea that you take the top diagram, you turn it upside down, you're going to get to the right structure. And that gave us that. This was then actually an interesting sketch by Norman where he was talking about how it would float over this rather beautiful Gothic revival building. And that was the final drawing, and you sort of see then how it sits and how it related to the pediment. And there was a lot of work done just to make sure that, you know, the exact geometries and the alignment between the existing building and the new building were really, really close. And there's a section through it in the final building. So you can see it's all surrounding, but it's actually the big space in the middle. It's not dissimilar to the British Museum, but we'll see why it's crucially quite different in a second. That's what this was a video originally, but we've managed to lose the video. This was a script back in the day. This is what it looked like. It was not a grasshopper. It was a script. You had to have very specialized people. There was probably only about 10, 12 of them in the entire industry at this point who could do this kind of stuff, and we had a lot of them in our practice. And why did I get interested in it? I got interested in it because I began to see that we could do stuff with this that was not necessarily just related to geometry. People at the time are very, very interested in geometry, and you can see what it's doing, but maybe it could be doing something else. Maybe it could give us a much broader sense of how we could compose architecture. Sorry, if it was a video, it would just be going through and you'd see lines and lines of computer code. This is what a very quick render looked like at this point, interesting enough. So it's quite hard at this point to judge what you're going to do. Even a good render is not looking particularly great. So we had to find out another version of life of how we were going to do it. And that's sort of the object, effectively, that we were creating with its 8 holes. And this is actually very close to the final model. So effectively, it was a glass roof. Quite interesting, and I'll see in a minute. There's some complexity as to how we did it. But yeah, a relatively simple object. This is interesting for me historically because it was almost the first model that we'd made where we'd used the data from a digital piece, and we couldn't 3D print it at this point, but we were able to sort of use some CNC machines to cut the ribs out for the roof, and that was the first time that we'd done that, and this was the competition model. And there's the final building, so probably in about 2005, just showing what it was, and you can see that it doesn't look, it's not completely the same as the British Museum. It's got a greater depth in the beams, as we'll see, and it also crucially has squares rather than triangles, which if you try and do a 3D surface with squares, you'll realise there's some issues around that, which need to be solved. And I think this was the point really why it was so different for the British Museum. They were going to use it for, they weren't just going to use it as a through space, they were actually going to use it for events, they were going to have loads of people in it, so the acoustic side of it was massive. It could not just be a bouncy, reverberant space. We had to do something very, very different within it. So whether we had an 8-second reverberation time at the BM, this was the original one, which was 3.5 seconds. If we just put the glass roof on it, we'd have ended up with about 8 seconds. So what we actually needed to do was to put as much absorption as we could into the roof to keep it back at that number. So it felt like the place, interestingly enough. You didn't want it to be lower than that because it would then not feel right for something that was a stone courtyard. So it was a really interesting balance. You always wanted it to be invisible for the purposes of acoustics. Now, and this is where we're going to start. So this is really, to me, where the innovation piece started, was that right in the design phase, what we started to do was rather than keep thinking about it and keep going, right, we're going to just think about it as designers, we're just going to try and work this out, even with our advanced scripting. What we started to do, and this is in schematic design, we started to get into making full-scale mock-ups, really beginning to understand how the thing was going to really come together, because there was so much complexity that you actually had to start mocking it up. And this is the first one, and you can see what we were doing at this point. We're going, right, okay, we've got some acoustic stuff, so we're going to get these bits of metal, and that's probably the answer. But yeah, it didn't turn out to be the answer. Everything's sort of off on the skew a bit. There's actually me, a very young me, sitting behind Spencer de Grey. But yeah, this is then, it sort of generated over time. I thought these were interesting. It's very fast if you look at it, because you're in the design phase. So every month we're making another mock-up. We're putting it up on a crane, and we're having a look at it. And then what we're doing is then channeling that back into the script. So we're going, right, okay, right, we can take the physical, we can basically test it, have a look at it, see whether we can build it, and then we'll get the script to respond to that, and then we'll generate back the whole roof. So yeah, clients and everybody looking at it. And at some point it goes between being rather twisted, and we got rid of some of the twist, decided we didn't need it, and it becomes a little bit more, it looks like it's rectilinear, but it really isn't. And that's where it went to. And that's then, again, your sort of picture at this point. So this is 2004, we've done these kind of mock-ups, we're looking at that, and that's what the 3D model's kicking out. That's what that lovely load of computer code is kicking out at the same time. But this becomes pretty powerful, because what you're then really worried about is how can you directly relate the physical to the digital. So you're doing both things always at the same time in the design. The scripts are going forwards, the physical stuff is going forwards all at the same time, and I felt that was really powerful at this point. And it became a key tenet to then what we introduced in the practice, to how to both push production scripting very, very hard, but also how to mock up things and how to get within our contracts mock-ups that would constantly be testing what we were doing and how we were doing it. So yeah, there's a shot of the final one, interesting enough. So it shows you how the beams are going and what that then looked at. Rather beautiful shot of how the column increases the depth and width of the beams to resist the puncture forces that will come through when you look up. And the whole thing floating over the original building in those terms. So yeah, quite an interesting piece. This was then, I said I'd come back to this. This is like again, I love these sort of renders from 2004, but yeah, this was the problem. You've got lots of square panels sitting on a roof. How are you going to do that? Well, actually how we did it was not join them together at all, not try to join them together. We just allowed them to sit and create these little origami triangles. I thought I'd put a detail in for you. That's how it works. These sort of planes are actually little triangles that are cut out with CNC that then allow you to create this thing. Danny wanted me to put this one in. That's what the data set looks like at this point. It's literally an Excel spreadsheet. You're sending it out, sending it to a contractor, have this Excel spreadsheet, put it into your thing, put it into your production piece, and that's then how that is going to work. There was a mock-up that we were doing, which begins to tell you when you look a bit closely what we're doing. So again, in the production, we're constantly really just testing this before we get to site. We're not trying to do it just at the end. Yeah, it's quite interesting, that one. And then this was sort of on the way through as well. The whole thing's built in Germany. It's made in these big bits. They kind of build it on the floor again, the script sort of defines that. They weld it together, and then they ship it over, and that's a really cool shot of it halfway complete. So you can begin to see the sort of layers of what ends up making it. And then this rather fun surface, which is which almost nobody sees, weirdly enough, which is this sort of incredibly cool kind of glass here, beginning to look almost solid. And I said to somebody earlier, I'm a bit of a one-trick pony, and this is maybe one of the things that I've got quite interested in, was this idea of how glass actually is a solid material. And when you look at it in a certain way, you can really deal with it in that way and think about it as this rather super surface thing that you can play with. So yeah, that was the top surface, which again, nobody sees, but we kind of thought was pretty interesting in those terms. And there we are here, still got the title in the corner. I thought this was interesting because now this is a bit later and the landscape's actually grown properly, but this is sort of typical situation. I didn't want to spend too long. Again, so imagine that was a long time ago. In the intervening 20 years, the workflow has really gone supercharged, but the fundamental principles are the same, of really dealing with a lot of heavy-duty scripting within the workflow, and then thinking about how we can constantly be taking that and taking it back into the physical world, mapping that, putting them both ways, effectively. So I'm going to start with this. This is a 400-meter tower that I'm building at the moment. It's almost complete in Shenzhen. This is the bay in Shenzhen. If anybody's from Hong Kong, Shenzhen, they'll know where this is. So you've effectively got a big piece of water in front of you. Hong Kong is sort of that way. And yeah, we're sort of in a drone at the top of the tower here on the way up, which was quite interesting as the site. You've got effectively a big park coming, as you can see in the foreground, which is up against the bay itself, and we were linking to that park and effectively creating a sequence of spaces. But really, as we'll see, the point of this building was to look out at the bay. Yeah, there's the site diagram, the red block being the site and how it would sit in relationship to the park. And it was going to have this stepped form that was going to relate to some of the wider master plan. Yeah, there's the basic diagram, I would say. So we put the lifts and things to the back, and that was going to effectively make all the space look out at the bay. And I'll go through this sequence, which is quite interesting. This was really what we were after. We were after effectively having people standing out into the view. So you had this sort of idea that, okay, if it was flat, you know, it's sort of one-dimensional experience, but I really want to be right out there. I want to be actually feeling like I've stood out and I'm actually into the space itself, into the volume of the bay. Yeah, so to give you a sort of size and scale, it's about 10.5 meters between those columns. So it's quite a big, it's a big building. I mean, let's be frank. So that sort of idea was key. We weren't convinced we wanted to do it all with curved glass. There's a lot of issues around curved glass and how we talk about solidity, but there's some very funny reflective pieces that happen with curved glass. Doesn't make it ideal to do this kind of thing with, but also we weren't sure that was going to be quite enough in terms of how we wanted to do it. So we sort of started thinking about paper folding and origami and how we might actually make a building that had a texture of its own. And that led us into doing something like that. So we effectively basically folded a sequence of triangles this time and created the bay out of triangles. Yeah, and that's a sort of look of it. The building's quite fun, and it's actually about 60 or 70% solid, this building, but still has these amazing panoramic views. Give you a sense of scale. That's the size of one of those triangles. So it's bigger than you. It's about 4 meters by 2.5 meters, which is quite fun. And there was, yeah, again, a little model of what we're doing, a little prototype of that piece. Yeah, that was the sort of conceptual image. And then I had where you sort of stand out to the bay. Is it going to need another click? Yeah, so that was then I did this picture on site. So there you are, you're looking across from the bay and you're actually in the building itself at this point. So what do we mean by a scripted workflow? This is sort of beginning. I'm not the scripter. So if you ask me detailed questions about the scripting, I'll have some version of it. I might be able to tell you what I was trying to do, what I was asking, and usually people come back with some really odd stuff, and it may be the script sometimes moved the building in its own right. I don't think it's not just a tool. It will define the buildings at some point as well, as you begin to see. But this was, yeah, the idea of a fully scripted architectural workflow. So every element of it is effectively controlled by the scripts, if we want it to be. There's very little of it that isn't. It doesn't matter whether it has a fancy geometry or not. We don't worry about that. We're just literally, we're using as much as possible. We're going to use the script to sort of generate it. Yeah, this is just a little exhibition of some of it. It's gone back to actually being an Excel spreadsheet. This Excel spreadsheet is actually controlling the model on the right, and it's controlling where the social spaces are in the building. So you're effectively, you can, click a social space into the building and it'll change the model in real time, which was quite interesting. Did lots of versions of that and prototyped loads of them. In terms of, effectively it looks and feels a bit like a bundle of sticks. And this was this rather beautiful model. Again, it's one of the most beautiful models I've ever seen. Again, created in our model shop down in Battersea, which is, I think we probably have the biggest model shop in London. You know that or not? We certainly have the most sophisticated model shop in London. And they produce just absolutely wonderful work. This one is all made of stainless steel and etchings in stainless steel and bits of robot cut perspex, I think. But it gives you a sense of it. It's about 400 meters. And stepping down towards the bay, and there it is. So that's the actual building, as it was last week, maybe. Yeah, I was there last week, so yeah. And we can see sort of ideas. I won't go into the full design today because I'm talking about something else, but there's sort of ideas about how the landscape comes through it and how it drags people from the bayfront into something else. What you're looking at in the different colours is that this is effectively reflecting the land, and as you go higher you're reflecting the sky because you're right next to the bay. So effectively all you're seeing always is how the surrounding environment is reflected in the building. It's very neutral to its actual colour. It's simply reflecting the sky, and we'll talk about that in a minute in terms of how we mock that up and what we were trying to do with it. This again, yeah, so I've got a few of these things for those people who like scripting. And what it's doing, but yeah, you can imagine, so everything has sort of parametric control. This makes it look relatively simple, but it's the relationship between these relatively simple pieces and then the wider scripts that will give you a fully detailed model of everything. That looks a bit like the model, but it's actually the real building. Interesting enough, the side elevation has this sequence of sort of almost lozenge-shaped pieces that come up on it, and these are then all the these are sort of garden spaces that sit within the tower. This is one of my favourite pictures because it sort of begins to describe some of the intellectual side of it in a way that it's made up of these sort of blocks. And what became really interesting is it becomes constructed like this, as we'll see in a minute. But also it feels a little bit like a Brancusi sculpture. And I used this picture, and this was actually from our exhibition that was at the Pompidou Centre, and the Brancusi sculpture was there because there's quite a few of our buildings that sort of have that nature to them, that they actually come from there. And so it's very much that kind of idea. Hopefully that'll run. Yeah, so this is just, again, it's never going to be this thick, so this is just looking at the degree. So once you change that first piece, you can change everything with it. Everything is effectively variable. And allows you to make the whole thing up. But so you have a lot of control over what you're doing. You can do it in detail. You can do it and it's a building of 150,000 square meters. So the size and scale of the building relates to that. It creates a very complex overall piece. And this is the size of the mock-up we're using at this point. So yeah, it's about 2 bays of the building. There was the core on the back of it. So it's a very big object, and we're testing that. We're remaking it lots and lots of times. And I thought it's really interesting that you just consistently see it almost like a block, like a sort of piece of that Brancusi sculpture in a way. And I thought that was very interesting for how it then went. Omniverse, just a quick piece about Omniverse. So what is Omniverse? This is, as you begin to talk, you probably realise, and we'll see some apps that we've written. We're a bit like a tech company. This was us working with another tech company, which was NVIDIA. And I actually went out to see Jensen, and we were talking about this. So this is effectively a real-time render software that we were doing some beta testing with them on. And so the idea being that you'd be able to do real-time versions of your building. And as we'll see, it'll begin to come into maybe a second thematic of the talk about how does the digital get ever closer to the real? Or how does the digital get ever closer to the actual, and what does that mean? Okay. Yeah, this is sort of a basic explanation of it. Here they were changing everything and making the tower made of copper, which was quite fun, but yeah. And you'll see on this right-hand side, what becomes absolutely key is actually what materials you're putting into it. And you probably all realise that, this idea that I'm going to go and choose a material. So I've got to go and choose a material. I've at the moment only got certain materials I can use. They're not particularly like the actual materials. So I'm a bit limited with what I can do. I'll then take it into Photoshop, and it all becomes very subjective very quickly. That is a bit the point about this. This second part of the talk is about how do you remove some of that subjectivity? How do you get a bit closer to the real between the two things? Yeah, those are the renders versus the real to give you a sense of it. So how close it's getting is quite interesting. So that again, the point that actually the thing that's different, and it's fascinating why it's different, is not the materials, even at this point. It is actually the context. So the fact that you haven't got an amazing context to put into your renders and to put into your simulations of a building is actually probably the biggest issue you have in relationship to how real you can make something. So if you have a sky dome, an actual sky dome from the site, that gets pretty close, but then you need to see it in different times of day and the rest of it. So you sort of end up with, that's actually really where it gets to, I think. I think that's why it's slightly different. I did this is just a sort of, this was a little time lapse we did, just looking at that front facade, just looking at how it would change in the light and how the little stainless steel cover caps are picking up the light. Whenever you do something in stainless steel, it just sort of bounces the light, which is a lot of fun, and it makes sort of strange geometries that repeat for the whole height of the tower, which begins to become quite a point. As the sun comes round, you begin to get different colours that get picked up directly into this facade, and that was, again, something that initially we didn't think would happen, and we saw some renders that came out of. One of the little rules of this is you keep seeing stuff and you think, well, it'll never look like that, and it turns out it will at some point. So yeah, there it is at the end of the day. And then we're looking at this shot, and again, this is actually a real photo, the one on the right, and the raw render, when we saw it, we literally said, it's never going to look like that. There's no chance we're looking like that. So you can't necessarily trust yourself on this, because you always, it actually tells you something slightly different. Again, another detail for you. I thought you'd like that. That's sort of how the variance of slope on the facade works. And this is quite a fun drawing. It still seems to some point want to hit a contractual set of drawings. So that's actually what the set of drawings looks like. Again, there's lots of sort of flat data in it. Ultimately, is it really that, or is it not that? It's kind of, it probably is still the transfer of a model in reality, but this is sort of where it goes to, this incredibly dense data set. I'm not sure I'd do that now. It's quite interesting. It's probably 5 years ago. I probably wouldn't have done this now. This is fascinating. It's bad quality because I was in a trade show in Shenzhen, and this was taken on my phone, and this is something from the contractor, and they're talking about how they build this thing. What I loved about this is that, and you begin to see it when we'll see it in the building, they're literally making it as we designed it. They didn't make it out of lots of little triangles. What they really did is they went and built these really big bits, and they sort of hoisted them up onto the building, as we'll see. So it comes like that. It then gets into a robot. You are making a jig for the panel, each of the panels being slightly different, well, within a stack, which is quite fun. That then goes on a lorry. It's critically about the size of a lorry, and it's something that can get to side. This bit's quite fun. There are actually rails on the facade that it goes up, so it gets hoisted in, and there are actually rails in the columns that it runs up and down on. So you've actually got, within the physicality of the building, you've got the methodology of building it, which is interesting in its own right. So yeah, it slides up into place, and then it goes in to the building. So that's how they'd said they were going to do it, which is quite fun. This is another shot. I thought this was quite fun. We actually have an all-female site team on this one. This is Grace and Aisha, and they're looking here at actually a piece of stainless steel. It's a stainless steel gridded frame that we had for one of the special spaces. This is one of my favourite shots. This is like a lovely construction shot, because it sort of really shows you that idea, that sort of Brancusi idea can be actually in the final building, and it's in the construction of the building in itself. You can see those big panels there and what they mean. So it's a 10.5 by 4.5 metre object flying up about 400 metres on rails, slotting into the building to build it. One from the inside. This is one of the special spaces. This is actually the cladding that we were looking at, the two women were looking at on the ground when they were going, right, okay, get that right, sort that, weld out. And yeah, this is one of the bigger social spaces, I'd say probably about 250, 300 metres out by the look of that. And I'm just going to go to this bit. This is another big thematic. This is something that changed we sort of talked about at the start. We began in 2004, we didn't have all these people, but we began to really get into an idea that we wanted more voices, we wanted more expertise, we wanted to have more of that in-house. So what we did is we had lots of different people who were going to add to the design discussion. And you could add this and you could go, you could go anthropologists, you could go data analysts, you can go model makers. There's lots and lots of, effectively the one nice thing about our practice in a way, it's now about 2,800 people, so it's a big piece. But we have maybe a third of those people are not architects, and they're doing something else. So it adds to that discourse. These specialist teams, and again, there are two of these which are very key, we're looking at some of the work of, in fact, maybe three of them or four of them. So applied R&D is is effectively probably our digital R&D piece. Probably it's best described as that. Specialist modelling group is probably as physical R&D piece in a way. They do cross over a little bit. Materials research is fascinating in that it probably links into both of them, and then we'll see a lot of this down here in the model making side of things and how that all relates also to the model makers and how model making has come onwards. We thought this would be quite fun if you like that kind of thing. That's the coordination workflow for CMB. So that's the sort of flow chart of where the digital information goes and how it goes in terms of the various models. So you sort of start off down here and it ends up in a kind of big circle. This data gives you something else, and this was something that I thought you'd all find quite interesting in that it does give us this ability with the data sets that we have to actually apply carbon counting to that piece. And so this is effectively the life cycle carbon of CMB being done from the data set that we're looking at. And the idea that could be real time with your scripting is really interesting. So you can do that, you get all the carbon data in there. You change something at one end, you can actually kick out a different number at the other end. So if you want to make a carbon conscious building, if you want to make decisions that you're going to make about structure or the facade or whatever you're going to do, you actually can see the implications of that within the piece. And this sort of ends up as something like this. There's the facade in terms of thousands of tons, interestingly enough, or thousands, so yeah, tons of different pieces. And there's the frame, which is actually much bigger numbers, as you'd imagine it would be. This is an interesting bit of tech, and again, I'm just sort of focusing on a little bit how we work as a group together. This is called Hermes. This is an inbuilt app that we have, and effectively what it does is it allows our different data sets to talk to each other, so we can get real-time interaction between our data sets. For anybody, again, it's not all going to be a bit techie, just so we all know. I'm not going to talk about this forever. This is just, I'm in the techie bit of the talk. But you get what I mean. So effectively, we created quite a simplified communication protocol that allows different scripted models to talk to each other in real time. So we can change something, it'll change something else, and it'll effectively keep it within a sort of single type data set. Yeah. So that's quite fun. At the moment, this is completely internal. That's partly because we're just not a software company. We've built it for ourselves because we want to use it. So it is what it is a bit. But at some point, it'd be quite interesting. But it really is about a collaboration tool, the digital collaboration tool. And that then takes it, we did all the engineering on the bank, so we did all the levels of engineering and landscape, so that then took us to all these other great models that kind of built up the overall piece. So yeah, it's not, so I think one should not only think, if I can get everybody into that mindset that this digital stuff is not only useful for creating fun geometries, it's actually really a production piece, in reality. That's what it's really very, very useful for. Yeah, there's a column, just to give you a sense of scale. This is one we didn't quite believe this at the time, so this was a column at the ground, sort of the size and scale of it. It's my friend Patrick standing next to it. This is a sort of classic thing. You lot have been asking, well, how we made this? Well, this is made of foam sprayed silver to kind of make it feel a bit like the size of the column. But that's how big the columns actually are, about 4.5 meters by that. And that was the data set, looking at those columns and how they change over time. So yeah, that ability to link this all into quite a major structural model was quite fun. And it ends up as something like that. If you like coordination, you end up with this sort of fully coordinated piece of which actually those initial scripts are now looking like really just the edge, aren't they? So in terms of the overall piece, that bit's looking quite small in comparison to the overall set of data that we're using. This is the bit that was actually on the poster. Interesting enough, we got to the top space. We have a bit of a history of trying to do something with the tops of buildings. So in the top space, what you'll see really is that, so we had a single space that's up there, and we didn't really want the column to interfere with that front wall up there. So what we did, and you can begin to see it here, this is actually Danny's drawing. I said to him, find one of your drawings, Danny. So there we are. So it's this space here we're looking at, and this wall. And that was the picture that we saw on the poster. I say it's really interesting, single volume for the bank that they would use to present with, this kind of thing. Some very big bits of window cleaning kit. If you look at them right on the top of the bank, which are good. This was, again, a second of the contractors' videos, so telling you how they built it. Again, I just find this stuff, I told you it was a bit niche. My apologies. This is how they were building that. Effectively creating a sequence of things that would slot together, having put this kind of background framework in, and then they're sort of bolting it all up. And what it really creates is a sort of stainless steel surface. Because it's triangulated, it doesn't need to have secondary, tertiary members on it. It effectively just becomes a surface of stainless steel triangulated members. Which is interesting, because it takes it to a place where you just think, okay, I can, as an architect, I don't necessarily have to think in the old way of, okay, I'm going to do a support system and I'm going to do a curtain wall. These things are going to be rather different. In this, it's all one thing. The triangulation helps you with that. Yeah, there they are, putting the... If this is in Mandarin, I can tell you they're really going for it at this point. But they built that, and then, yeah, there it was, on the way through construction. This was again on site. You can see they've cleared the scaffolding away now. They hadn't cleaned the building at this point, so that's why it's all a bit dirty, and you can then see how high we are in comparison to the mountains here. This is literally Hong Kong, and there's the bridge that goes over to Hong Kong over there. And that's the image looking up, because the column's been removed from it. Effectively, it's a 0.5, which it looks a bit random, but effectively you have the two bays of the building, and there's nothing in the middle. The surface has just flown round the middle and given us an ability. But how does it work? It works because it's really a load of stainless steel members that are triangulated together and give you an ability to utilise a single surface. Lighting, yeah, we had some fun with the lighting. So each node, we decided we were going to do something where we're shining down the cover caps. So each node has got 6 little lights in. And that's rather beautiful. In the end, this was actually the mock-up. So the mock-ups are not used only for testing of geometry and daytime stuff. They're actually doing the evening stuff as well. So there is a picture during the day, and that rather beautiful thing is where it is during the night. So you then get this kind of grid of light that comes over the whole piece. And we were doing that to effectively give us, and to be fair, it photographs a little bit stronger than it actually is. It's a bit more subtle than that. It's very hard to photograph. So the final bit of the talk, or this part, the second part of the talk really, or the third part, is Apple to CMB simulation. This was a problem that Apple said to us. We do a lot of the Apple stores around the world. And they'd said to us, what we really want you to do is we want you to be able to tell us what the thing's going to look like in advance. We're not really interested in just finding out. We want the renders to be very, very accurate. So that was a very interesting challenge for us as a very technical architect. How do you make that happen? So this was a very early one. This was Apple Regent Street, which you probably know, and that's the reality, and that was the thing. So can you get something that's rendered that actually looks incredibly like the final thing is going to look like, and what does it mean to do that? So your client's there, your client's Apple, they're saying to you, I want it to be exactly the same. And there's some interesting bits around this. I love this picture because it sort of tells you the sort of craft part of it, people mucking around, people doing engineering, kind of like saying, okay, how do I mock up? These were actually tree lights that they were doing. This is actually a little tree light piece. So they're performance testing light fittings. They're getting exactly what the performance of the light fittings are. So what's in the renders is not generic. It is very, very specific to the light fittings that are actually there. They're then doing fixture prototypes and looking at how this is how they lit a tree ultimately. Looking at how that, really mocking it up with the actual tree, beginning to kind of do work on that, looking at that. And this is really what we were after, interesting enough, was how this sort of, the tree creates these rather beautiful shadows on the walls around it. How does it actually get that sort of natural sense from the tree? How do you project that into the stainless steel pieces around you? And that's actually the one in Seattle where that one was, all that mock-up was for. And you can see where it's going is almost creating something a bit like a paper pattern on the wall over there. But that's very purposeful, and it comes from this idea of how do you mock something up to create these kind of things. And it's the ephemerality that you're really trying to get to. So now we're going to look at the combination of physical testing and the virtual environments, which is quite fun. This was the lobby that we had at China Merchants Bank, where we began to use this on a bigger scale. And this was the sort of detail of one of those cove lights. So we basically had this little sort of pocket. This will become a bit clearer in a bit. And we shone an LED around from each edge, looking at different heights of it, working out how it was going to go. This was a very early mock-up. In fact, I'm standing in front of it. And what it is, that's the material we're going to use. But this thing is just made of printed cardboard with in the model shop. So it's just basically trying to give us an early version of it, something we can do very fast to get a sense of what that detail is going to look like. We then took that to site, and I thought this was just for me, a bit of learning as an architect. We took that to site, got very obsessed with different materials. And like, is this the right color? Is this the right color? No, it's not. Right. And we keep doing it. And actually, when it came down to it, if I look at the next one, we found that really the color of light was the big question. So we could use different materials. We could really almost choose a relatively generic gold material if we wanted to, and we could play with the kelvins of the light to make it be whatever color we wanted it to be. And it was actually, the most fascinating thing was it was going to be different in the day and the night. And I don't know, I don't quite understand why it is. I think it's some of the background light was a bit more blue in one, obviously in the daytime, but you needed a slightly different color of light to let your eye see the same thing. These were the big mock-ups that we then did on site. This little process of digitalization of real material, this is probably a big thematic for you. If you have ever thought about AI and where AI may or may not go, this is probably one of the biggest questions of it, is that it can render things that it knows, but it can't render things that it doesn't know. And if you're really going to get to something that is really like the simulacrum of the actual real world, you need to have a very, very full-on data set of material. Much bigger data set of material than you think you've got at the moment on your render machines. Much, much bigger. You need to be able to say, okay, I want that. Okay, I need to see exactly what that is. And I need to have all those data pieces. So that's a sort of 3D scanner, an earlier one. But you begin to create very, very complex data sets out of the materials, which is quite fun. What's that then? All right, okay. This was, I think we're missing a picture, aren't we? Yeah. So actually, what we did is we got the client into the site, and the client was on the site in the space, and we had the VR goggles on, and we were playing these renders out in VR with them, and we were going, right, okay, you should stand there, and you should see what the final space is going to be like, and we'll change different things, and we'll have a look at it. But yeah, one's a photograph and one isn't. Interesting. The right-hand one, I think, is the photograph, but it begins to tell you where you begin to get to in a VR, which is pretty close. Again, we haven't quite tuned the one on the right yet, but that was that one. This was the model that we had of the entrance. This is like a normalized render. This is what we thought it would look like, which is pretty close. I think the stainless steel is slightly out, and I still don't quite know why, but that's actually the reality. So I think particularly in the cove lighting, they're very close. I think the difference isn't actually, it's slightly to do with the photography, to be fair. I think that the photographing stuff at night, I think it looks much closer to that. Those big red things are 5-meter bronze lions that you have outside a Chinese bank, protecting you. You see the size of a person, then you get how big the lion is. And then that was sort of the second part of this lobby simulation. There's the simulation and there's the reality. As I say, I think it just picks up a little bit more of the exposure time. And that's the daytime. It's actually a different color in day. And that's why this is actually the same light Kelvin being used, but that is interesting that it looks much warmer at night than in day, and that's literally just the external color of light bouncing inside, giving you a different read. Now, my final piece, crafted, not crafted. So that's the stuff that's actually in front of me here, and this is the final piece in this talk. So this is Salaya, which is in Dubai, and it's effectively these buildings that sit around this, which is actually going to be very good, because it's going to be a public beach park in Dubai that hasn't existed. It is a public area, but it's not really a beach park. It's a sort of slightly depressing retail piece at the moment that doesn't really work. So it's going to become a beach park. But the buildings around it was something that we were doing the beach park, we were also doing the buildings around it. And these buildings looked a bit like this. They had quite strict zoning pieces to them. But what we wanted to do is effectively create quite a vertical order to how we were going to hold some of this together. And within that, we decided we would do these stone walls. And these stone walls would be very rough. You'd be next to them and you'd experience them, and there's a piece of it here. You'd sort of touch it. You'd really feel like it was quite a sort of natural material in many ways, or was a natural material in many ways. And again, some more technical drawings, which we thought were quite fun. This was just looking at the sizing of things. Now, so we have effectively, how do we get a design stone? So we were at one point, here was the natural stone that we'd sort of chosen and we thought was going to be really good, and it's, so we could probably lift the lights up a bit. Danny, would you like to come and give me a hand? So there it is. So that's a piece of Omani limestone. It's a bit marble-like, and it's got lots of cuts through it, and then somebody's hit it with a chisel. And that's created what is rather beautiful. Oh, right, there we are, look. And that's what's going to be on there. But actually, even on this, you can begin to see that when we're trying to make it look like that, we didn't get very far because it's very, very natural. It's very random. And so what we ended up doing, that was the one that looked a bit, could we get it from looking like this, which is too much repetition, to actually doing something where actually we didn't have any repetition. We had it feeling. Yeah, absolutely. Yeah, as I say, this was a grasshopper script. It's a pretty sophisticated one, but is it going to go? Yeah, so it's quite a lot of it. But effectively, I think what it's doing, and again, from listening to the guy who did it, and what I loved about this is he literally just went away and did this over a weekend. He'd sort of come up with some idea of, right, I better work out how to script stone, and he worked out how to script stone over a weekend, which was quite fun. And we then, what we were really doing is we're going to take this stone and we're going to think, okay, could we look at different textures? Could we look at different ways of doing it? And what was going to be the right one? We actually ended up being very close to our final one, but that's what we were doing with it. We were going, right, we're not sure we think this is exactly the right texture, but we don't necessarily want to go and just do all this slowly by going to ask somebody to do it. We're going to do it faster. And this is how we did it. So once we'd got that model, which was scripted stone, we were then using our robot to cut it out, and that's actually probably cutting this one, interesting enough, out of this piece of foam. And it's giving us something that was really from the physical. We'd taken it to the digital, and we'd then thrown it back into the physical world to do the testing of light falling on it and the rest of it. So to get a sense of how that was going to work. There we are, a robot going over foam. This was our client, and we're sort of judging it there with some of the other materials. So what we're doing here is we're just walking a massive way away from it. We're looking at different light conditions with it. So yeah, we're beginning to always, I think I said earlier, and I maybe didn't say it hard enough, there's a great, you can see rendering being done. You can see rendering being done in that sort of simulation stuff, but really what we're trying constantly doing is to test the digital world with the physical and make judgment calls in both places rather than make judgment calls only by saying, well, I looked at the render, I thought it was fine. We're always trying to do a big mock-up or do something that tells us that. That was the palette of materials. And that was, yeah, this was actually the final, this was one that we then took that back out to Oman, and we were looking at that in a big mock-up. You can sort of get it here, yeah, big pieces of this and how it was working. It was pretty hot. That was in July this year, I think. That's my hand, looking at the texture of the stone. And I'm going to finish with this. So this again, I think is really interesting. Again, it's an early version of life, and there is a piece historically in architecture of testing architecture at a scale, and what's the right scale to test it at. And I'm going to just sort of finish there in a way. It's like, so we developed a little bit of stuff around either 1 to 10 or 1 to 5 models, and then it's sort of how close to reality can we get those models? How close to actually having the textures, the reflectivities, and everything with the final building. So yeah, that was the sort of size of it. So to give you a sense, yeah, we're making a model that's about 2 meters by 1 meter, 2 meters square by 1 meter as a piece. Yeah, there it was being constructed in this massive model shop, and you can see that all those stone pieces, the same script that's created that has created this, has created 3D prints. If anybody's done a lot of model making now, they'll know there's an awful lot of 3D printing within model making. That was the overall piece. That's the overall big picture of it. And here we are, yeah, we're looking at, okay, well, what's the joint between things and how does that work? But actually, it's very, very close to the final materials in terms of it. So in that, we thought it was very interesting that you can, not only in 1 to 1, but also 1 to 10, you can actually get a lot from it. You can actually get the fall of light on it, and it is going to work. And that's why I'm going to finish, yeah. So that's now coming towards the end of its construction drawing phase. So yeah, we're almost at the end of that. So I'm going to end there really just to sort of talk about, you can see in that this sort of obsession between how the workflow works. There's lots and lots of tech within the workflow, but constantly going back to crafted things that actually allow us to judge that. Okay, and that was really the point of this. If you have any questions, I would love to take them.
Thank you, Dan. Any questions? Yes? No?
Maybe not. Or we could do it more informal. You can come and have a look at the stuff and we can talk then.
Well, I was going to ask about what happens to the... I quite like the idea of these big mock-ups, and there's quite a history in architecture of making these big... You know, Eres Saarinen did... The office made these big mock-ups of projects, and I sort of wonder what happens to these big pieces. Do they end up as houses or kind of small pavilions?
The big one on China Merchants became the site office for somebody for quite a while, and then that site got taken over by DJI, the drone company. There's like a Renzo building going up next to it, so at that point I think they disassembled it. I don't know what happened to the Smithsonian ones. They're probably in a field in Germany somewhere. But they're not really inhabitable in the same way that was inhabitable. So yeah, I mean, I think it's an interesting question. What's really fascinating, I don't think you ever regret building them. You get so much from them and they change your mind. If you look at the Smithsonian one, the design completely changed during that sequence of mock-ups. It's not the same. It's not what we did at the competition time. It changed completely by looking at it like that.
Thank you. Stunned audience, no.
Sorry, was that... Yeah, I did say it was a bit niche, didn't I?
No more questions? No. Yes,
Here we go.
Yeah.
I just wondered if you could say a little bit more about... You talked a lot about the direct shift from the digital to the physical and the role of the model and the mock-up and the scale models. Is there a role in the drawing part that starts to kind of translate scale in some way? Because you're only in the mock-ups, you're clearly getting a very specific piece under whatever the light conditions are at the time. And I just wondered if you could say a little bit more about how you develop either side of that process.
Yeah, how we develop which bit and why. Yeah, I mean, I think the drawing side is very interesting, and I think it's probably, I would say, one of the biggest struggles at the moment is how to produce architectural drawings that have a sense of being architectural drawings and don't just feel like they're pictures of something else. So that's a big piece in its own right and probably worthy of discussion as to whether that's right or wrong and what that means for us all. It is certain that some of the drawing side of things is still done very informally. We're doing loads of sketching, and you're seeing a lot of the finished work here. It's going through a lot of stuff where it doesn't look like this. It does, it's looking very messy at lots of points, and thankfully messy. I mean, I think if you had a studio that was too tidy, it would be a problem in a way. You want to have a lot of ideas and a lot of things thrown on the floor in a way. The key issue is you'd probably want to mock up, let's say, in your own version of life, you'd go, well, I'd love to see all of it one-to-one before I build it. And you've got to make a judgment call about how much you're going to do and how much your client is going to pay for during that. So that's part of it. We tend to do what we sometimes call Frankenstein mock-ups, where they literally have bits of the building of different sides. If you looked at the back of that big one in China, you literally got bits of the core cladding and you've got bits of the side, and it sort of all comes together. So you're sort of trying to judge different things, if this makes any sense, rather than just going, I've got this one piece of building, but it is a bit of an incomplete science, and it is a financial piece at some point. But I would also say any client who's done the mock-up sequence has learnt so much, and they've also been much better when they've come to the contractor and gone, right, okay, I need to build this. They really know what they're doing before they get there because they've built it already. I mean, it's a very, very different conversation when you're actually trying to get somebody to then construct it for you. I don't know whether that was what you'd asked, but close enough.
Hi, thanks for the talk. Very interesting. How, in the sort of development of the practice over 50 years, where it starts off being, very much Norman Foster's signature. I'm not sure how much Norman is still involved.
He is still around, yes.
These days, but you're obviously, it's a huge enterprise now. It's a very different thing to at the beginning. But so, how do aesthetic decisions get made? I mean, obviously, this is part of keeping a very close control on the aesthetic sensibility of the building. But how, in a sort of strategic way, do you maintain across such a large organisation this, if you like, a kind of aesthetic brand, and who's in control of that, or is?
But this is a really interesting question. I'd say it's probably twofold. One is that we are not interested in a barrier between us and our clients. We want our clients to be absolutely in the middle of the design process, making judgments with us. We do not want to be the architect who goes, right, I've decided, this is what it is, this is what you're going to get. We literally are there with our clients. They are making the same value judgments we are, and a lot of this process is about giving that to the wider project in a way. How can you get enough information out there for you to make a considered judgment about a piece of architecture? I think the quality side of it, in one way, and I'll answer it in a completely different way in a second, the quality side of it in one way is that the process allows you to really investigate a sense of what the architecture is going to be and to try to resolve pieces within it and really have a detailed consideration prior to construction, and hopefully way in advance. And by doing that, you do inevitably get a level of quality from it. There's then another piece to it, which I think you can't underestimate. Most people at Foster's who are a bit like me, most people who are senior there, they started there from their part twos and they've gone through 30, 40 years of being there, and therefore they have within them a very big stored knowledge. And particularly there's a group, which is our design board, who are, some of them have been there an awful long time, and they have a level of experience about this stuff which is quite off the chart. And so you have that kind of, you have ongoing reviews constantly, both internally, but I wouldn't want to put the client out of that conversation, because that is ultimately it. I mean, in that shop when we were looking, that is the client. We're on the left-hand side, making a judgment call about what we're doing and why we're doing it. So I'd like to sort of, I think it's twofold. It's both, you have inherent experience within the company. It's not neutral. And it's been quite stable for a long, long time. It constantly is trying to innovate, so it's why it's not the same. Why, I thought it was interesting, you look at 2004 to now, it's very, very different. Some bits are the same, some bits aren't. Yeah? It's why, we were talking earlier, I've been there for 30 years. Why am I there for 30 years? Because it just changes all the time.
So you're kind of saying there's an embedded philosophy that is as a result of the longevity of.
I think so, and the people there, and I think Norman's leadership in terms of, and what I feel is really positive about it is it doesn't stay still. What we're interested in doesn't stay still. I think if you would go away for 5 years and you come back, you'd think you're in a completely different place, and the whole conversation would be completely different. And that's what I think is really positive. And part of that, and I'm going to go to another picture and I'll try and explain something. I was actually not going for that. I was going for this. Now, or maybe this. This idea that a young architect, in fact a part two, moves out of the AA, has come and they've developed a system within the business and they've innovated within the business on their own back to do something, which we're now happy to talk to you about. I invited him to come out tonight. But I thought that was really interesting because that is, again, part of the process. It's not only about the longevity of things, it's about having an open mind towards where innovation comes from, and that anybody can come into practice and actually begin to create innovation and begin to create a different way of doing things, because you cannot keep a workflow stable. It has to constantly get better. Constantly. It's got to get faster. It's got to get better at understanding architecture, better at the complete picture in some sense.
Going back to these mock-ups, obviously these are amazing mock-ups that are very helpful for architects and also the client and the contractor, but if you have to redo them, they can be very costly. So I was just wondering if, as a company, you negotiate with the contractors prior to construction for this risk and this cost that they might So is this something the contractor covers?
Yes, no. So if they're going to be really useful, you've got to do them a lot earlier than you think you're going to do them. So I talked a little bit about the ones on the Smithsonian. They were, whether they were done at concept or schematic, but they're like really, really early. They're before the contractor. The contractor might be appointed very, very early in that process, and you've really said to them, okay, as part of your contract, we want you to do 5 mock-ups, and we'll get that priced within the number. I think historically what a lot of architects did is they sort of left it, they'd drawn it, and I think that the problem is just trusting too much and having a little bit of arrogance that you could draw it out or render it out and you'll get it right. And I think you have to be able to open up to, and again, it's a very Foster thing in a way, you have to open up to the how you build something and get that experience into the architecture. I thought that the CMB cladding panel, which was exactly the same as the sort of piece, is exactly that in a way. It's like how you build it, what the architecture is, it's all one thing. And I feel that openness to understand, so if the contractor comes with something and says, okay, right, I can do this in a different way, or have you thought about this? You need to be open in your mindset to say, okay, yes, well, let's have a look at that, let's test that, and see whether it works or not. It's not a one-way street of, okay, it's all going to cost more money, because it might actually, through the mock-up, you might actually be refining how they think about it and refining what the risk is as well. So hopefully, again, I don't think you can see it as a negative in that way. Although obviously, yeah, it is definitely part of a process that somebody's got to anticipate early.
So something I'm wondering is, because you guys develop lots of plugins and tools. Okay, is this working?
It is.
Yeah.
No, you're good.
Okay. Lots of Grasshopper and Rhino plugins. How often do you release them? How often do you collaborate with Rhino on new tools and new ways in which the software can be used?
Yeah, I think we're changing a little bit. You probably saw the first Rhino plugin come out of us, which was the environmental one, the sort of slightly Minecraft environmental one that came out. I think it was early this year, but I might be wrong. The Cyclops one, did you see that?
I think it was this summer, right?
Yeah, so it's a real-time environmental model thing. I hate to tell you that's very trailing edge in-house, but that's one of the reasons it was sent out. It was a good thing to do. I had a very interesting philosophical question the other day with people as to whether the release of the tech was going to have a bigger sustainability impact than all the buildings we might do. Weirdly enough, if we release the tech, if we release the ability to measure carbon in the way that we can do it, if we release some of the environmental modelling tools that we have, would that effectively make a bigger difference to the world? Question.
So do you think this is the way forward? Are you going to be releasing more of your tools?
I don't know. It's possible. I think, yeah, this kind of, ultimately we're architects, and we're architects, but again, we're a bit like a tech company. Whether we're really like a tech company is probably on the way. But we definitely do stuff that I think what we've realised is you cannot rely just on the things you're given by industry. You have to be able to innovate within it, because you won't get what you want from it, and you'll only get a certain look of building. If you look at Revit per se, it produces buildings that look like Revit buildings. You can see them all around the world. They all look the same. They all have the same horizontality in them, because the architects have made them in a certain way on Revit, which is maybe the answer to some of the drawing problem that sits there, is that the means of production relates to the architecture that we now see. So yeah, potentially, I think people are interested in it. It's probably one of the bigger parts for the next few years as to where that goes.
Thank you.
I think the one that is potentially very useful is Hermes, but I'm not sure where that's going to go, because again, it's a relatively simple thing. But it does create interoperability, which is just amazing. That was the the one where everybody's talking to each other around the table digitally. Yeah.
Well, look, thank you very much, Dan.
Got one more.
Yeah, we've got one more question.
Thank you for the talk, Dan. Just looking at your presentation, and we can see there's so much control, especially using scripting, computational design. We're wondering if they're kind of, is there like spatial kind of surprises that happen from real life kind of construction?
Yeah, definitely. I mean, I think, and I think that one of the really interesting things for me as an architect, again, I tend to believe that you should be a total architect, so you should be able to go and win international competitions, and you should also be able to build buildings beautifully at the other end. I don't think there should be any difference between you as an architect at both ends. I think you should. I'm not really a believer in specialization in that terms. So I think one of the great sort of learnings from that and building buildings is that you do find stuff that surprises you spatially sometimes. It's most often scale, I would say. And I think that is probably to do with how you perceive things within a computer screen sometimes, or even on a drawing, is not quite enough for your brain to really sense what the space is. We've done some interesting stuff sometimes of kind of demarcating spaces. Again, imagine a mock-up that just talks about volume rather than talks about the detail of something. And you say, okay, here's the room that you're standing in, and I'm just going to give you some indications of what the edge of the room are to give you a sense of how it feels to be a human being in a volume. And I think that's equally very valid, and that's, as I say, that's probably the bit that you probably most get surprised by, is what the volumetric side of what you're doing is. How does it feel? I think that other piece about the colour of light, that really surprised me. I did not have in my head that there would be a differential colour of light needed between day and night. That was like, nobody had ever said that to me. And we literally tried that on site. We were just playing with things and going, right, okay, that works. That now looks the same. And it's something also about a sort of judgment about what the human eye does is different to what the analysis might say. And I think that's, again, maybe a liberating point, is everything that might seem that it has to be the same, that it has to be technically the same, isn't necessarily how we react to things as human beings. And that's why the actual testing of it is really interesting, is because by testing it, you get to see what you feel about it, not what you were told or what you're being told is the data. And I feel that, I don't know whether I'm explaining that particularly well, but that's what I feel is very important about it. It's how you get the human being in the middle of it is probably the point of all this, is not to just allow it to be digital, to actually allow it to come out of that and to be something that you experience.
Well, thank you again, Dan. Thanks a lot.
Thank you.
Go and look at the samples, everyone.